I know everybody is hungry, so I'm also hungry, so I'll make a very quick presentation. So I did the first analysis of Tesco. We did the analysis on my 3 years ago, and I joined 3 years ago also. And they all told me, oh, we have some data to play with. So I'm very happy because data is very important too. And that was my first time also to analyze refrigeration data. I'm used to analyze brain images, and that's a very big difference. Okay, so yeah, so basically, yeah, we did this very fast because I had to port some of the codes from Tesco, and because of the Tesco work that was very comprehensive, it becomes very easy for us to analyze further other data set. The good thing with the data set is that, for example, with Tesco, we can develop, for example, a certain kind of coding or algorithm, and we apply that immediately to all stores. We even just using one store, it's so consistent that we can immediately spit out the results in seconds, and all the other stores are following the same trend. What we have with this green-yellow is that out of 65 data sets, I think around 9 data sets have some problems, but it's still a big number. So it gives us a good starting point to see which of the data sets are behaving normally and those data sets that are behaving abnormally. So what we summarize here are those some of the data sets that are good examples and those data sets that are bad examples, which is very good collection of data set. So for the first one, what you will see here is that this is just the slice of 15,000 observations. So this is like 1,000 observations. What you can see here is that the defrost state. What is the main difference also with the Tesco data and the green-yellow data is that in the Tesco data there's a defrost flag. So the first thing that I have to develop is that how do we detect the spikes, which are the defrost. So it took me like maybe 30 minutes to do that, so it's still okay. So basically what we did is that the good thing with this is that the steady state is so consistent that I can just get like one standard deviation or two standard deviation and consider that as a spike and count the number of them over the total number of days, and I can immediately compute the average defrost every day. And what you'll see here is that if it looks beautiful, it seems that it's very consistent. So the steady state average is -24, so this will be a very deep freeze. And then the standard deviation is around 61, and the number of daily defrost is 1. And the percentage of valves that are open for the 15,000 observation is around 67%. And then you'll see here that the month-by-month consistency is good. You have the defrost frequency, which is good also. And then the quality of the data is good. So this is a good example. Let's move on to the second example. You will see here now that the picture is different. It's some kind of anomaly you will see. Here, for example, you have 6 defrost now. So it's getting higher. And 162 days. I don't know if this is the policy that they have. And then the defrost, the steady state is -1.6 degrees centigrade. And then the variance is quite high, 1.22. And 45% of the valve are open on the average of 50,000 data points. What you can see here is that the defrost max point is drifting down. So it seems that at this point, actually, there might be no defrost at all, or if the defrost is very, very, very fast, such that it did not reach the ideal temperature of defrost, which is around.
Just to clarify, that's the overall temperature, so it's not S5.
Okay. I'm not the engineers here, so sorry for that. So of course, here we have this event flag which says that there's a drifting here, which we need to investigate further. So what we have here is just like a first bird's eye view of the trend, and then you can deep dive more. So for the third example, you will see here that for the first two examples, you will see that the defrost frequency are consistent, but here you will see that the defrost frequency is quite chaotic. So what you will see here is that the event flag is the defrost frequency consistency. For the rest, they are okay. Okay, and we move on to the last example, I think. What you will see here is that in the previous examples, all the steady states are flat, but here there's a trend. So somewhere here, the event factor that you'll notice is that the consistency of the steady state. Also, you will see that the variability is also high, and then the event cycle is also quite high. I think I will leave to Niall for the rest.
That's the final slide anyway. That's literally just obviously as part of your analysis in terms of the steady state variation, you're looking at the actual cutoff temperatures for the actual for the case. So you can determine what those cutoffs are, and you can see here just purely in terms of the variability across cases that were kind of HD cases. You're looking at -3 to -1, much tighter here than this. So that data again comes for free out the back door. And again, just for us, it would generate an event flag. There's something going on here because you're looking at this just purely as the cutoff temperatures there for that LT case. It allows you to look at it and see what the variation and distribution is. So I guess what we're trying to show here is that it literally is a lift and shift, and applying it literally within, once the code had been kind of modified, this was available. We did this in an afternoon, I guess, or not even an afternoon, in an hour and a half. We just literally spat these out, and these were of the 70 cases that we looked at. These were the 6 or 7 that popped out of our analysis for further view. Okay, that's it. So that's the end of this session.